Welcome to this introductory video on electronic engineering. This video will explain the fundamentals of logic, how it is represented in truth tables, and how this surprisingly simply allows you to design circuits for many use cases. Firstly, we explore logic as controlling a switch. Computers use logic to make decisions by turning the right switches on at the right time. For example, how would we turn on a blue dot on a computer screen? This circuit drawn shows a possible way to turn the light on, depending on whether the switches are on or off. Typically, we tell a computer to do something by using code. This is interpreted and passed through many aspects of control circuitry that is built into computer hardware. This then tells the switches to go from the off state, represented by a 0, to the on state, represented by a 1. In turn, the electricity can flow around the circuit in order to turn the blue light on. This behavior is represented on the table on the right. This table is known as a truth table. Typically, we call the off state false and the on state true. The left-hand side of the table denotes inputs, and the right side denotes outputs. In this case, the output is only true if A and B are true. Otherwise, the output is false. We can see that we have many truth tables to express different behaviors as follows. The logic gate we have seen in the truth table so far is called an AND gate. We also have OR and NOT gates. These are the simplest gates we have, but there are others we can explore later. Before we go any further, it is useful to understand how, despite having learnt a few basic rules, we can already design circuits to control systems. In this case, our specification tells us that we want a circuit that receives numbers and turns on the blue pixel on the screen when an even number between 0 and 3 is received. In order to design this, we need to find a way to send instructions in a way a computer understands. This is by switching on and off. So we use binary, which has only two states and represents everything as either zeros or ones. We can see that each bit, or each digit of binary, is expressed as descending powers of 2 as we go from left to right. We get the number 0 by doing 0 times 2 to the 1 plus 0 times 2 to the 0. Hence, we get the binary representation as 0, 0. The other numbers use the same system as shown. We set up our design by drawing a truth table, listing all possible input combinations as shown. We then use our specification to decide when we want the output to be true. In this case, our output is true. That is, the blue pixel is only on when we receive the number 2, as it is the only even number between 0 and 3. So this tells us we need a circuit that outputs a 1 only when A equals 1 and B equals 0. As this is a very simple case, we can see that we only need a NOT gate and an AND gate. Hence, when we write some code that turns the blue pixel on when a 2 is recorded, the computer can use this circuitry to make it happen in reality. We conclude this video with some final remarks. This video has introduced the basic introduction to digital electronics by looking at logic. These concepts have then been used to produce a design, as shown by an example. Like and subscribe for more.